sorry.
Much better.
Okay, so this is a talk about iminuit, past and future, and I'm giving a talk, but there are actually many people contributing to this, have been contributing to this project, so try to mention that. So yeah, iminuit is the frontend to the minuit C++ code. This minuit is a general purpose tool to minimize statistical cost functions with box constraints, and what's kind of unique about it, it can also compute parameter uncertainties. It's a robust technology from 1975, so that stood the test of time. So quite reliable. And yeah, okay, that's I already said. Yeah, and of course, minuit, because it's more or less the only way to compute parameter uncertainties, is more or less used by everyone. Internally, it uses an algorithm called migrat. What this does is it does Newton steps. So it has quadratic convergence near the minimum, so that's nice. With a somehow updated approximated Hessian matrix. And when this doesn't work, then it falls back to a steepest descent with a line search. And then it has various heuristics to deal with sticky situations. Box constraints are implemented via parameter transformations. That's what's good and bad. What's kind of remarkable is also this stopping criterion that it uses, which is very well suited actually for the use case, how we use it, because it's sensitive to both the minimum values and their uncertainties. Yeah, talking about uncertainties, there are two ways implemented. They're computing the Hessian matrix, and then there's this MINOS algorithm, which does a profile likelihood scan. And both of them you can use for 1D and ND intervals, or ND would be contours then. And those respect the box constraints. So that's of course, I mean, you kind of take this for granted, but this is also well, somewhat unique. Yeah, and then I don't know which one is better. It's debatable. Surprisingly ambiguous. A bit of history before going into some demo. So as I mentioned, this is a origin one. The version was in Fortran from 75, and then it was ported to C and integrated in root in the 2000s, and then there was this independent rewrite in C++ called iminuit2 or iminuit in the early zero years, and this is now also integrated in root, and this is what we are using, this iminuit2. And then on the Python world, so the first wrappers for this code were written by Jim Pivarski, called pyminuit and pyminuit2. And this already had a nice feature, this auto detection of parameter names that's still there. Then iminuit was developed as a rewrite by Pity Ongmong Konkul, and he used Cyton as a wrapper. So originally it was just direct wrapping in C. And he tried to, I don't know whether this is fully true, but he tried to be an interface compatible with pyminuit. The I stands for interactive, so he cared a lot about having pretty displays in Jupyter notebooks, and that's still a feature of iminuit. So there were intermediate maintainer was Christoph Dahl, who was the leading developer of GammaPy, and then I took over in 2018, and iminuit joined PyHEP, which was very nice, very fruitful, I must say. So then they came out version 1.3, which had tight integration with NumPy. And one important feature of that version was also you can now modify the fit state. So iminuit was always designed, and is a key feature as a state machine. So you do fit something, and then you change some aspects of the fit, and then you fit again based on that previous state. Yeah, we will see later how that is actually useful. So this was not possible with iminuit before, now it's possible. We also integrated better code sharing with C++. So now we regularly update the C++ code and have it in sync with the root version. So we can also profit from the changes that root people do. And there are nice Python wheels and conda packages. And a lot of credit here go for the Python wheels to Henry. And these other people who take care of the conda packages mostly. So I don't have to do anything about it. So that's really nice. And yeah, so there was also lots of documentation and tutorials added. So I really recommend, if you're interested in this at all, to try out the iminuit tutorials on Binder, which Binder link was added by Matthew Feichert. Yeah, lots of bug fixes in interface. So I mean, iminuit works, of course, but the interface of iminuit was not so not so easy to use. There were some inconsistencies and so on, and I'm continuously working on that to improve that, to make it easier. Yeah, and one thing maybe, so you can also use, can now compute Hesse uncertainties at any point in your cost function, not only at the minimum. So in principle, you could use iminuit Hesse as an afterburner to some external minimization. Yeah, and then the latest version is 1.4. So here the new thing is mostly, again, trying to make the interface better. So a lot of duplicated and legacy interface was deprecated. So it's still usable, but it's not advertised in documentation anymore. So these changes mean getters and setters, which were replaced with properties, and similar objects are made to work alike. And we comply with NumPy and Python expectations, so that dict-like objects have a dict interface. And when you access the parameters, then you can use nice broadcasting and slicing syntax. I will show you a little bit of that later. Yeah, and in general, I would say this consistency pays off in the long run, because it reduces mental load when you use this and makes it easier to teach and learn iminuit. Yeah, there's also PDG rounding rules now for the iminuit displays, which is kind of nice superficially. And one of Lay's features is that cost functions were added. This doesn't have anything to do directly with minimization, but I will tell you why I think this is still useful. Also, iminuit tool code was updated to the latest root version just recently. So here's some example of the list of what deprecated interface is not, well, you shouldn't use anymore. So it's still there. You can still, all the code should still be working, and we are also continuously testing this so that it still works in the future. But when you read the docs, you should not see the left side anymore. You should do all these right-hand side stuff. So I will not go into the details. But I hope we will all agree that the new versions make more sense. So why would you use iminuit and not some other tool? Some other tool, maybe roofit, PyHEP, or zfit. I mean, if you use one of these tools and they work for you, great. No reason to use iminuit. Why? I mean, iminuit is simple and it's universally applicable, so that might be useful sometimes. It's nice when you want to teach about fitting. It's good enough for simple fits. Well, and I actually use it mostly because I'm an expert in power user, and I find this, well, I want to have full control over my fit and try new things, and this is nice with iminuit. So in a way, you could say iminuit is this knife here where you can cut anything with, and even saw stuff. But I mean, there are other tools which are heavily specialized and work much better and faster for specific problems. Okay, so how does iminuit work? I showed this here on the simple fit. So yeah, you import the stuff. Here's some random data that is well, Gaussian distributed around some line. And now we want to recover these parameters of the line. So we make a little function here that predicts the y values as a function of x and two parameters a and b. And then we have to write a cost function which we minimize, and somehow this cost function should be minimal where the best values of these a and b parameters are achieved. And we do this by, well, computing the square sum of residuals. And then we plug it into iminuit, give some starting values on a and b, and some error definition here, and then we let it, well, we can look at the parameters. Initially, it's just the values that we set. And yeah, so the nice thing is that iminuit automatically detects the parameter names from just looking at the function signature here. So use some introspection, nice feature of Python that C++ doesn't have like this. And then you run the actual minimization step by calling migrate, and then this gives you this nice output of iminuit. Everything here should be green. That means that the fit was okay. It took 34 function evaluations. And these are the final values here. So, well, I put in 1 and 2, and it kind of recovers them. Errors are small. And this display here uses the PDG rounding rule. So it gives you the shortest possible number of digits that makes sense. So one thing that I want to note here, if you want to judge your fit, this EDM value is very important. It's this estimated distance to minimum. And this should be smaller than the goal. And if that is not smaller, then iminuit really didn't find a proper minimum. Yeah, and this other parameter that's kind of important is positive definite. So this should be true. If it's not true, then the Hessian matrix, the matrix of second derivatives, is not, well, it's not indicating that this is a minimum. We will see later an example how it looks like. Yeah, and you can now get all these features if you need them in a program by just using the fmin attribute. Yeah, and here's how the fitted result looks like. So I just plug in here the model and I take this is the way how you get the values out of minuit with this values attribute, and then the slicing syntax here gives you a tuple, then expand the tuple, and yeah, this is how you plot this. Yeah, there's lots of information in this fmin object here that you can look at when you print the representation, and it shows you all the fields. So this is kind of a struct. If you want the other kind of errors, so I mean, it automatically computes the Hesse errors. If you want the minus errors, you have to explicitly call this because this is extra work. And then the output is this. So again, this can fail, and therefore you have to look at these things are all green. In this case, it was a simple case, so where the error is the same, whether you use minut or Hesse. And when you then call this dot params again, this has a nice display again here, and you will see now the minus errors columns filled in. If you want to programmatically access them, you use this nerrors thing, and you can put in here the name of the variable, and then you get some struct deck that has lots of information that you can query. Okay, now I was talking about interactively manipulating the fit state, so let's do that. Let's fix the a value to 1 and run migrant again. And this is what you get. So this is how you set it up. You just set it here with this syntax here, and you fix it to true. I hope this is straightforward, and you run migrant again, and now you get this result here, and the table tells you, yeah, it's fixed to 1 here. This still has the error from before, but now it's kind of meaningless. And the v parameter, if you still remember the value, was a little bit below 2, and now it's a little bit above 2. And maybe good to mention here, it just took 8 calls here to get that result because it was already pretty close to the minimum. And this is the feature of minuit, that it can converge faster when you already were close to the minimum. So this is this state machine aspect that I was mentioning. And now we can play around with this. You can try different values of A and always run migrant and scan through B. And I just did this for fun here. So I mean, you can do all kinds of things that you with this feature. Yeah, and you can plot all these different solutions, and then you get these funny lines which have somehow a fixed point exactly here. Okay, yeah, then I want to talk about these new cost functions a little bit. So we now have some built-in cost functions directly in minuit. So this doesn't have anything to do with minuit directly, but it's kind of handy. And I mean, there's not a lot of code to have this. So yeah, what we have is unbind negative log likelihood, extended, unbind, and then the bind versions also extended and not extended, and least squares. And the least squares thing also has an option to do robust least squares fitting. And nice thing is, so this, if you used minuit ever, then you had to always worry about this error def parameter, and this is somehow taken care automatically by these, so you don't have to set that. So let's try this out. So on a more HEP physicist typical case, so we have a peak above background. This is how it looks like in a histogram. And then we do our extended bind log likelihood in this case. So make a histogram of this, and then we define our signal model here, or a normal distribution. Background is an exponential, and then we have to add this to describe data. And this has 5 parameters, and then you make a cost function, plugging in this model and your data, and then you plug that into minuit, and you have to give your starting values, and then you run migrant run, and then you find, it doesn't work. So I give you here how you would do this probably. You usually run into a problem first. So it didn't find a minimum, and when you look at the values, they are basically close to the starting value. So this doesn't work. So what happens? And there's a way you can look into this by setting verbose true on your cost function, and then you run it again. And it will give you this output here. On the left-hand side, embraces are the current parameters at tried. On the right-hand side, you see the function, the cost function value, and you see there's lots of nuns in between. So that's not good. That's a sign that something is not good. So yeah, the point is that minuit doesn't know anything about mathematics, what you put into your model, and it turns out that our sigma for the Gaussian has to be larger. I mean, has to be positive, and our lambda should also be positive. Otherwise, these are not mathematically defined PDFs. So we have to set limits on this. This is how you do it. And then we run again. And then it takes a long time and still fails. But now the values look kind of not so crazy anymore. Maybe still look crazy. So this value here, the amplitude of the background is super negative. That's not good. Okay, so here actually, when we look closely at what it reported is, so the core limit was reached. So iminuit has this core limit, so it doesn't run forever when you have a flat cost function, for example, which has no minimum at all. And yeah, here we ran into this limit. So we can increase the limit and try again, and then it still fails. And now when we look at the solution this time, I mean, it seems to have converged. It says, it's a valid minimum. But it was not positive. The fuzzy matrix was not positive definite. And this is how the solution looks like, which is not a solution at all. So in the end, it converges something where the background is basically negligible, and it tried to describe the data with the peak, with the signal component only, and this doesn't work, of course. So what happened? I mean, the problem is there are several issues here. So we used really bad starting values. So iminuit was not able to find the right minimum from that point. And you can then fix this by, for example, using this masking feature of the cost function. So you can mask out the peak and only fit the background by fixing the signal to 0. And when you run migrate on this, this is how it looks like. So now we have a nice description of the background. Great. Then we can fix the background and fit only the peak. And then you get a good solution. And that's rather easy with these cost functions and this masking feature. And then in the end, you would just, when you have that, you again on the same iminuit instance, you would just let every parameter free and run migrate again. And then it very quickly finds the final solution, the full solution. Yes, and this is a typical way how you would work interactively with iminuit. So final note, so you can also set the limits appropriately on all the parameters, and then it finds the solution right away. So it's mostly a matter of not fixing the limits here before. And well, we set some limits on this lumped parameter and sigma, but you should also set limits on the other parameters, and that works. And when you set the limits or not, you get the same values actually. You can check that, and with some sources claim you should not use limits overly carelessly. That's true, but if as long as the parameter doesn't really converge exactly at the limit boundary, you should be okay. So there are some people who are, yes.
Quick interjection. Just yes. When you're scrolling, scroll more smoothly.
Oh yeah. Okay. I try that.
Thanks.
So how much time do I have left?
15 minutes 15 minutes including questions.
Okay. Mm-hmm. Yeah, 5 more minutes, that's fine. So then I show you how you can combine iminuit with resample. So resample was I showed on Tuesday, and I claimed that this bootstrapping is quite nice and useful. So in here I show you how. For example, you can use this to check the errors that iminuit spit out, whether this makes sense. And yeah, what I do here, so I load this bootstrapping method, and this is the original fit here, now with proper limits, so it immediately finds the right minimum. And then I start my bootstrap resampling, so I sample new data sets from my original sample, and I compute my histograms, and then I just assign to this n, which is just the histogram counts. Histograms are all shaped the same way, so that's all I have to do, and then I run migrate again. And this works very efficiently because migrate already is close to the minimum and just has to update the minimum a little bit now that the data has changed just a little bit. That works very well, as you can see here. So the original fit took 600 function evaluations, so it took a long time, but these resampling versions, they take something like 30 to 40, sometimes 100 iterations, and this is a histogram. So this is really nice how iminuit can accelerate this. Okay, and this is how the errors look like. So now we have all these resampled estimates, and we can just compute standard deviation using this covariance function from NumPy. And here you see a comparison of the error estimates from iminuit and the one from the Bootstrap, and they nicely agree. And this is how you would use the Bootstrap with iminuit. Okay, so future plans. I think minuit is fine as it is. There's really, well, we could use it as it is, but maybe at some point it would be cool if we could replace the Seiden bindings with PyBind 11 bindings, because Seiden is really lacking behind C++ features and it works, but we have to do lots of workarounds in iminuit to make it work, because Seiden is good for C, but not so good for C++. And PyBind 11 has no problems with, we can accept any C++ idioms, and it's not a separate code generator, it's just a C++ library. So obviously it works, and that wouldn't make a lot of sense, but it's a lot of work also. One thing that this would easily enable is full support for Unicode parameters. So right now you can just write parameters in ASCII, but we kind of get used to using Unicode in Python, so it would be cool to support that. And another thing that would be useful is if the minuit object was pickable. I just told you that the state is quite nice to preserve. And if you would run, if you want to run something in parallel, maybe you want to pass the same iminuit object in parallel to do this bootstrap in parallel on several processes. And if you use a multiprocessing thing, then it has to pickle and unpickle the object. And currently that's not possible, but you should probably support that. Okay, and yeah, check out the other iminuit tutorials. Yeah, and with that, I want to close.
Thanks so much, Hans. So you were a bit shy saying if you're using other tools, no need to change, no reason to change. But in fact, two of the examples at least that you gave actually using iminuit as an engine.
Yeah. I mean, but the question was, why would you use it directly? And I mean, if you
no, but that's
PyHEP and this works for you, then there's no reason to change to iminuit.
But it's a key thing. Yeah. But, do you want me to share the questions? There's 3 questions there for you.
Yeah, please.
Quickly do that. I think I can override you. Yes, there you go. So first question: Can one store serialize the current state of the minimizer to a file such that one can load it in another process?
Yeah, so that was the thing I mentioned in the end. So this is not possible right now, but we should. I mean, if you're also asking for it, then I'm even more convinced that this is a good idea to have. So yeah. I mean, it's probably comparably easy to do superficially. Whether we can restore the full internal state of iminuit, I don't know. But I mean, I guess everything is better than the current state where it doesn't work at all.
Mm-hmm. Okay, the other one. So, can you get Hessian from other minimizers, but then the uncertainties are hard to compare to minuit because the parameter transformations? Is there a plan to expose the parameter transformation code for given bounds as a public API?
No, I don't think so. I mean, we're kind of restricted to the API that minuit 2 offers to us, and I mean, they also don't expose this. So, but I mean, you can look up what the transformation is in the iminuit manual. It's not complicated, so you can re-implement this if you like. Yes, and yeah, sure, you can also get the Hessian in other ways. For example, we heard about JUX, which I also like a lot. So JUX can also compute Hessians. Yeah, but I mean, why would you? I mean, you can also compute the Hessian with minuit.
I mean, it's probably...
So this just came up from in PyHEP where, well, we use JAX and other frameworks to kind of do some of the minimization, but then we also want to have uncertainties, and yeah, it's I mean, yeah, it's easy to look it up in the manual, but then okay, I guess it's not likely to change anytime soon, and so maybe we just re-implement that. But it would be nice to kind of be able to use some tool that does this transformation for you.
I can look into this, but yeah, I think it's not so easy. I mean, you can, of course.
I think it shouldn't be so hard to construct the Jacobian that corresponds to the transformation, even analytically, and then you could multiply it through with the Hessian.
Yes.
Yeah, no, I've done that manually, but it's yeah, it's just a lot of time spent reading the minuit code.
Yeah, that's true.
Okay. Does Minos take into account the bounded parameters for the internal computation? For instance, for a parameter bounded to be positive.
Yes, so yeah, that's one of the key things. So because it has to do all these, so Minos actually does some minimizations while it's running to do the profile likelihood. And then of course you also don't want to run into an unphysical reason or a region where it's mathematically not defined. Then you would get nuns again and then it would fail. So it's very important actually that it does respect the bounded parameters, but you have to set the bounds. And as long as your problem is expressible with box constraints, like all the parameters live in a hyperdimensional box, as long as that is possible, it works. If you have something more complicated than a box, then you might run into trouble. But that's a fundamental limitation of how iminuit is built, as we cannot easily change this.
Yeah. All right, so Jan is asking, if you mentioned the at some point you wanted to factor out certain algorithms, for example, Minos. Is that still the plan, or?
Yeah, I originally thought that this is a good idea. Now I'm not so sure anymore. The more I learn about iminuit, the more I see it as really one integrated thing that is hard to take out. I mean, all the parts I learned are really well fitting together. So I mean, this minimization criterion EDN, this works super well with migrot, but it doesn't work with other minimizers so well. And also this idea, I mean, it computes the Hessian matrix anyway. So when it returns it to you, it usually just gives you the last thing it computed. So all these parts fit really strongly together. And even Minos uses the Hessian matrix to get a nice starting point for this search that it does. So I think, I mean, if it's, so the API doesn't really allow me to run Minos on a not minimized function. But I thought this is maybe it's something nice to have. So I will continue. It's on my to-do list, but it's not super easy to do. And taking iminuit into parts and including other minimization algorithms and so on is also something I considered at some point, but I don't think this is really, yeah, would help so much. So it's really one integrated package. It's hard to take apart.
Yeah, that is, I think, it's fair enough. Okay, so we actually have time to finish. Yeah. So there's a question also, iminuit and OpenMP, or in general, parallel programming. Do you have any comments on that?
Yeah, so we don't really need to use OpenMP. You can, of course, so your cost function, that's the one that is costly to compute. It's not called cost function because of that, but that's the expensive part. So you can already parallelize this. So you can use number or whatever to compute this in parallel. So iminuit itself spends very little time. It's mostly all time is spent inside your likelihood function. So there's no need to parallelize iminuit itself. You just parallelize your likelihood function.
And of course, we didn't have too many questions about documentation, so here's one. Is there any good reference with details on how the migrot algorithm works besides the source code?
Yeah. No, I mean, I encourage you to look into read the docs of iminuit. I mean, we try to give you really the pointers where all this is documented. I mean, there's the original paper by Freddie James that you can look into. That's fairly comprehensive, I think. I mean, that's what I use to understand what's going on. I mean, reading the source code is yeah, good luck with that. It's pretty hard. It's not because it's super complicated, but it's deeply nested somewhere, and it's even when I have to do this, it's always a mess. I don't like it to look into the source code.
Yeah, I don't think we should be inviting people to obfuscated code competitions. But I mean, if there's anything we can do to make it a little bit more approachable on the code side, it would help a lot.
Yeah, I agree. But I'm more or less, I think you would actually have to rewrite iminuit 2 again to do it justice. And that's not really, that's not feasible.
You mean we can't just use F to C and call it a day?
You can also do that. I mean, but then it's not iminuit 2 again. So whatever people changed in the meantime in iminuit 2 and made better, then you would lose that. So I don't know. I mean, yeah. I recently saw if you take root, if you just download the release and you compile it with standard options, it doesn't even include iminuit 2. It just includes the Fortran iminuit. I don't know what that means. So I have to ask some people.
Okay, are we good? Yeah, well, thanks very much again for the presentation on the essential tool and also for answering all the questions. Actually.